Good morning, all 11th standard students. We are going to learn today the first lesson in physics. Name of the lesson is Unit and Measurement. In the unit and measurement, it is necessary to all over the world to bring all the scientists in the world together and to work further research. So first we were going to study the fundamental quantities. There are in all 7 physical quantities which do not depend on which other quantities for their measurement. For example, here the length, mass, time, electric current, luminous intensity, temperature and amount of substance. So those quantities, they are not depending on other quantities and therefore they are to be called as fundamental quantities. The second quantity is called the derived quantities. Physical quantities which depend upon one or more fundamental quantities are called derived quantities. Example, velocity is derived quantity. The velocity is defined as the rate of change of displacement, that is, velocity is equal to displacement upon time. Therefore, here displacement means length and time means t. So L and t is present in this formula, and that is to be written as V is equal to L upon capital T. And further, that is to be written as L raised to 1 and T raised to minus 1. And therefore, this use is to be taken into consideration for the next physical quantity, that is, the second one is dimensions of a physical quantity. So while writing the dimensions of physical quantity, so in derived quantities, so we have to write the first formula of the first physical quantity, that is velocity. Velocity is equal to length upon time, and that is to be written as L upon T, and as L is in numerator, its power is 1, and time is in denominator, its power is T raised to 1, and further we can write it as in a square bracket, length to the power 1, mass to the power 0, and time to the power minus 1. Why we have written mass to the power as 0, 1 here? Because mass is absent in the formula of velocity, and therefore in the square bracket, if we write a equation in terms of length, mass and time by raising their power 1, 0 and minus 1, that is to be called as the dimensional equation of velocity. So while from this we can construct the definition of dimensional equation of physical quantity. So if powers of fundamental units are raised to obtain unit of that quantity, so therefore here in this case such a equation which is to be written in square bracket by raising the power of length, mass and time is called as dimensional equation. And similarly, we can calculate the further dimensional equations of acceleration. Acceleration is defined as rate of change of velocity with respect to time, and therefore the dimensional equation of acceleration is equal to dimensional equation of velocity divided by dimensional equation of time, and that is to be equal to, in square bracket, length to the power 1, mass to the power 0, and time to the power minus 2. And therefore, further we can write the same dimensional equation for force also. So, according to the definition of force, force is the product of mass and acceleration. Therefore, here the dimensional equation of force can be written in first bracket, square bracket, length to the power 0, mass to the power 1, time to the power 0. In another square bracket, we can write length to the power 1, mass to the power 0, and time to the power minus 2. And therefore, according to the rule of here, according to this rule, we further write it as force is the product of mass and acceleration. Therefore, in square bracket, the dimensional equation of force becomes equal to, in square bracket, length to the power 1, mass to the power 1, and time to the power minus 2. And by knowing this dimensional equation of force, also we can calculate the dimensional equation of work. So, from the definition of work, as it is the product of force and displacement, we write it as, so work is equal to force into displacement, and therefore the dimensional equation of work, first of all we have to write the, in square bracket, the dimensional equation of force, that is L raised to 1, M raised to 1, T raised to minus 2. In another square bracket, we have to write length to the power 1, mass to the power 0, and time to the power 0. Therefore, further the equation becomes, in square bracket, length to the power 2, mass to the power 1, and time to the power minus 2. So therefore, the square bracket is, in this square bracket, that is represented the dimensional equation of work. After then, power is also depending upon the formula of work, and therefore further we define power as the rate of doing work, and that is therefore power P is equal to work W upon time T. Therefore, we have to write it further in square bracket, dimensional equation of work as length to the power 2, mass to the power 1, time to the power minus 2, divided by, in square bracket, dimensional equation of time, and therefore L to the power 0, mass to the power 0, and time to the power 1. And further we simplify it further and write as, in square bracket, length to the power 2, mass to the power 1, and time to the power minus 3. So similarly, we calculate the dimensional equation of pressure. Pressure is equal to force upon area, and therefore that is equal to dimensional equation of force divided by dimensional equation of area. So there also we can write it as, in square bracket, length to the power 1, mass to the power 1, time to the power minus 2, that divided by length to the power 2, mass to the power 0 and time to the power 0, and we further simplify it and write in square bracket as length to the power minus 1, mass to the power 1 and time to the power minus 2. In this way, this is the dimensional equation of pressure, as pressure is equal to force upon area. So in this way, these are the dimensional equation, and this is used to find out the units of the fundamental quantities as well as the corresponding values of dimensional equation, and those dimensional equation can be written for further such different quantities, for example density, viscosity and all other physical quantities. We can calculate the dimensional equation, and in this way, so the first we have studied the first lesson. In the first lesson, that is unit and measurement.